This is question 8 from the CCEA 2022 reserve paper for A2 pure. So let's take a wee look. Quite a long one here. There's 3 different parts to it. So the curved surface area of a glass bowl can be modelled by rotating the curve y equals 3 tan 4x between x is 0 and x is pi over 16 through 2 pi radians about the x-axis. Find in terms of pi the maximum volume of liquid that the bowl can contain. So let's see what we have to do here. So my volume formula is of course pi upon the integral, and it says it's between pi over 16 and 0, and it's of, we got to square this, so it's going to be my y squared. So squaring this, remember, that goes to a 9 tan to the 4x squared dx. We can tidy this up very slightly, so we can pull the 9 out the front. It just saves us a wee bit of hassle. You do not have to, but it just makes life a wee bit easier. And tan squared is a bit of a messy one for us to integrate, but we do know that tan squared is sec squared minus 1, so I can change this then for a sec squared minus 1, and even though it might look like it's more complicated, this is actually much more straightforward then for us to integrate. So I'm going to have that. So my volume then becomes 9 pi, integrating sec squared, I don't know if you remember, so if you differentiate tan, you get sec squared. So if I integrate sec squared, I get tan, and because then it's a 4, it's going to be a quarter tan 4x, and then integrating the 1, it's minus x, and that then is between pi over 16 and 0. So that's then going to be 9 pi, and it's going to be a quarter, so that's going to be 4 times pi over 16, so that's pi over 4, and tan pi over 4 then is just going to be 1. And then subbing in, sorry, I need to have the 9 pi within that whole thing. Then it's just going to be 0, take away 0. Whenever you substitute in the 0 there, the whole thing then disappears. So how is this going to tidy up for us? It's going to be 9 pi upon a quarter minus pi over 16. And whatever way really you want to rewrite that, to be honest, I would kind of accept that as a final one. The mark scheme just incidentally is then taking the 16 out, so 9 pi over 16 upon then 4 minus pi, and because it's a volume, we're then going for cubic units, and it looks then like that. Part B, find the integral of x e to the 2x dx. So this here is shouting out to me is going to be integration by parts, so I need to assign something to be u. 9 times out of 10 it's the x, if there is one, and then my dv by dx is going to be e to the 2x. Finding du by dx gives me 1, and then v in this scenario here gives me a half e to the 2x. So using the formula then, the integral becomes uv, so that's going to be a half x e to the 2x minus the integral of v du by dx, so that's a half e to the 2x dx. And so my final line then is going to be a half x e to the 2x, take away integrating this, so just kind of integrating this, remember it went to a half, so remember the e to the 2x, when we integrate here it's going to go to a half again, so the half times a half, a quarter e to the 2x plus c. Use a substitution u equals x minus 3 to find the exact value of this, then between 6 and 4. So we're going to change the limits, I think is probably going to be a good idea to do. So change limits, my terrible writing there, and we know whenever x is 6, we take away 3 from it, and we get u is 3. And whenever x is 4, I get u is 1. I also need to find du by dx, so that's going to be me differentiating this, and that's a 1. So my formula then, sorry, not my formula, this here is going to become, it's going to be between 3 and 1. And I also know, sorry, rearranging this, that x is going to be u plus 3. So I'm going to exchange this here for a u plus 3. And that's upon then x minus 5. So that's going to be x. So I change that then for u plus 3. So it's u plus 3 minus 5. So it's going to be then u minus 2. This is x minus 3 here. So that's fine. So that's then just going to be u squared. And it's going to be then dx by du du. Now du by dx is 1, so dx by du is going to be 1. So that then is just going to disappear, and that'll be okay. So that then is the integral between 3 and 1 of u squared plus u minus 6 all over u squared du. Still looks a wee bit messy to integrate, but this is now going to tidy up for us. We can just divide each of these terms by u squared. U squared over u squared is 1 plus 1 over u minus 6. In fact, I'm going to write that as 6u to the minus 2. And now we're in a state where we can integrate this. So if I integrate this, I get u. I integrate this, I get ln u. I integrate this, so let me think about this. I add 1 to the power to turn into a minus 1, divide by the new power, plus 6, and then it's u to the minus 1, so it's going to be 6 over u. And that's all between 3 and 1. So substituting in then my 3 is going to be 3 plus ln 3 plus 2, and then substituting in the 1 plus ln 1 plus 6. So tidying this up gives me 5 plus ln 3. 1 plus 6 is 7. ln 1 of course is just 0. So that then is going to be a minus 7. So it tidies up to give me minus 2 plus ln 3.